Hey guys, welcome to Conceptual Geometry, Lesson 2.2, Angles of Triangles, Tick Marks, and Arc Marks. What we're going to do today, we're going to do 4 examples, basically kind of like fill in the blank for triangles. I'm going to give you a giant triangle that's divided up into other triangles and quadrilaterals. I'm going to give you a couple pieces of information, and from that you have to fill in every angle in the diagram. So one of the things in the title said tick marks and arc marks. If you notice here, we've got 2 arc marks. In geometry, that's a way of stating that those 2 angles are equal. Other marks in this figure that we need to pay attention to is this one from Unit 1. We know that's perpendicular, which basically means we have a 90-degree angle right there. So it doesn't really matter what order you do this in, and what's kind of neat about these puzzle problems is a lot of times you might do it in a different order but come up with the same answer. That's totally fine. So let's take a look here. I'm going to dive in first. I'm going to take a look at this triangle, because I know this angle is 58 degrees, and like we said, we know that one is 90 degrees. So if I wanted to find this angle here, I'm going to take 180 minus 90 minus 58, and that gives me 32 degrees. Well, since this has an arc mark and so does that means both of these angles are equal, so this one here is also 32 degrees. And not a whole else lot stuff. Suck. Now what I want to do is focus my attention here. Anytime we've got 2 lines that cross, I like this situation because it gives me vertical angles, so the angles across from each other are going to be equal, which means I can put 58 in right here. And it also gives me supplementary angles. So these 2 here have to add up to 180. So if I want to find this angle in here, I'm just going to take 180 minus 58. That gives me 122. And then the one vertical to that is also 122. So once I have those, now I can maybe take a look at some other triangles. For example, how about this triangle right here? I know 2 of the 3 angles. This angle is 122, that's 32. So if I subtract those from 180, I can get this angle up here. 180 minus 122 minus 32. Now I'd obviously throw that into the calculator. That gives me 26. So that angle is 26 degrees. Well, let's focus on this triangle right here. I know 2 of those angles, so I'm going to subtract those from 180 to get this one here. That's going to be 180 minus 86 minus 58. That gives me 36. And it looks like I've got, well, check this out. If that's 90, then this one on the other side of it's got to be 90. That's pretty easy. And right here, again, I have supplementary angles. We're going to see this all year long. So if I want to find this angle here, I have to subtract that one from 180. So that's going to be 180 minus 86. That's 94. So now it looks like I've got every angle labeled except for this one. This is going to be a little bit challenging. That is not a triangle. We're going to talk about quadrilaterals in the next unit, but right now I'd like to somehow figure out a way to get this using a triangle. Well, this angle is part of the whole triangle, isn't it? So if I can get this big angle here and this big angle here, then I can subtract those 2 from 180 to give me this. Well, before I do that, maybe I would combine these 2 angles together to figure out what that whole angle is. That's 62 degrees. And then combine those 2 together to get this angle. That's going to be 64 degrees. So now to get this one, I would just take 180 minus 64 minus 62, and that's going to be 54. Now I've got every angle in that figure. Okay, let's try another one. Given the following, find all the missing angles in the figure below. All right, so what I know here, measure of angle BAC is 100. Well, notice BAC is this whole angle. So I don't know what these individual ones are. You can't assume that that's split in half. So let me do something like this. I'll put a big arc with arrows, and that's going to be 100 degrees. I also know angle C is 30. Well, angle C is all by itself. I'm going to put a 30 right there. That's 30 degrees. Now, what marks do we have? Notice we have an arc mark there and an arc mark there, which means those two angles have to be equal. So guess what? This one up here is going to be 30. And this is really nice. That means that's a 90-degree angle, and it's part of this four-way intersection. So if one of them is 90, they're all going to be 90. So I can label each one of those right now. Now I want to try and get triangles if possible. Here's a triangle up top. I know two of those three angles, right? 30 and 90. So to get this one, I have to subtract those from 180. So that's going to be 180 minus 90 minus 30. That's going to give me 60. So now let's focus on this triangle. Sometimes it's a little hard to see at first, but notice in this triangle here, I've got a 30-degree angle and a 30-degree angle. So if I subtract those from 180, I can get this one down here. So that's going to be 180 minus 30 minus 30. That'll give me 120. Now, these two I know have to add up to 180 because there's my supplementary, my linear pair. So this angle is going to be 180 minus 120, or 60. Now, look at this triangle. That angle is 90, that's 60, so let's subtract those from 180. 180 minus 90 minus 60, that's 30. Now I can use this. The whole angle's 100. The smaller one here is 30. So if I subtract that from 100, that would give me the other angle. That's 70. And again, it doesn't matter what order. I'm just noticing something I kind of forgot here. Once I got this angle, I probably should have gotten the one that's supplementary to it right there. So that's going to be 180 minus 60. That's going to go right there. That's 120. And now I just need one more. I need this small one up here. Well, if you take a look at this triangle, that angle 70, that's 90. Subtract those from 180. That's going to go right there. 180 minus 70 minus 90, and that's going to be 20. And I believe I've got all of those angles. Great. Let's take a look at two more. Find all the missing angles in this figure. So let's pay attention to our arc marks. I've got a double arc mark here and a double arc mark there. So that means everything that's marked with two arcs is going to be equal. This angle over here then is 35 degrees. I've got a single arc mark here and a single arc mark here. So those two angles need to be equal. That makes this one 30. One thing we cannot do, and I need to caution you about this, you can't assume every four-way intersection has 90-degree angles. These are not 90-degree angles. I don't know what they are yet. We'll find them in a second. But as of right now, I don't know that those are 90. Now, this question is pretty difficult. I'm looking at this triangle. Well, I only know one angle. That's not even a triangle. This triangle here, I only know one angle. This triangle here, I only know one angle. There is one triangle where you actually know two angles. It's the whole thing. This is often the hardest part. So in this whole triangle, that angle is 35, and this one is going to be the combination of those two. So I'm going to add those two together to get this angle here of 65. So now if I want to get the big angle up top, which is made up of these two, I need to take 65 and 35 and subtract those from 180. So 180 minus 65 minus 35. And that's going to give me 80 degrees. So now, if this angle is 80 and that smaller one is 30, if I subtract those, so 80 minus 30, that's going to go right here. That's going to be 50. Now, I know it's starting to get kind of cluttered here. We got a lot going on. But now, if we focus on this triangle, I have a 50-degree angle there and a 35-degree angle there. So to get this one, I take 180 minus those two angles. So 180 minus 50 minus 35. And that's going to give me 95. So in this four-way intersection, the angles across from each other are going to be equal. So this angle right here has got to be 95. Then to get this one, I'm going to take 180 minus 95 because there's my linear pair, supplementary angles. And that's going to give me 85. And the one vertical to that is 85. So you can see, they're not all 90. All right, you can't assume that unless you would see a right angle symbol. All right, working my way around the figure. Let's take a look at this triangle now. That's 30, that's 85, so I'm going to subtract those from 180 to get this angle. 180 minus 30 minus 85. That gives me 65. And then notice here we have a straight line, supplementary angles. So this one here is going to be 180 minus 65. And that gives me 115. Now let's take a look at this triangle. And some of you might notice that we have a 30 and an 85, just like the one up above, which is going to make this angle here 65, because those two triangles are what we call congruent. And if this angle here is 65, that one's got to be 115, right? Because notice those two are the same, and that's 115. Crazy, look at all those angles. All right, I think I got them all. Let's move on. Last diagram. It says, given the following, find all the missing angles in the figure below. So here it says, measure of angle FAC, FAC is this angle here, is equal to FCA. So those two angles are equal. Let's put arc marks on them. This angle and that angle are equal. Measure of angle E is 36 degrees. Measure of angle BCD. So if we trace it, BCD, this angle up in here is 50 degrees. And measure of angle FAD, well, that's just this one right here, is 20 degrees. All right, so remember, single arc, those two are going to be equal. So if that's 20, that's 20. Got it. There's my symbol for a right angle, which makes this angle right here a right angle, or 90 degrees. Got that. And I need to work my way around the figure. Let's look for a triangle where we know two of the angles. This one right here, we know two of the angles. That one's 20, that one's 20. So to get this, we take 180 minus 20 minus 20. That's going to give me 140. These two are supplementary. There's a linear pair. That one there's going to be 180 minus 140. That's why that's 40. Once you get that angle, you have a second angle of this triangle. Now I can subtract those from 180 to get that angle at the bottom. 180 minus 40 minus 36. That's going to go there, plugging that to the calculator, 104. Let's focus on this triangle. That's 50, that's 90. Subtract those from 180 to get this angle down here. 180 minus 90 minus 50, that's 40. So close to being done. I need to find two angles. I need this one here, I need this one here. Now, unfortunately, if I'm looking at this triangle, I only know one angle. I don't know what this whole angle is, although we could find it. I want to draw your attention to this straight line. It's broken up into these angles. So all of these have to add up to 180. So I'm going to subtract this and that from 180 to get this one. It's not the only way. Like I said, a lot of times in these problems, there's more than one way to do it. You can do it in a different order. You can do different calculations. But if you came up with 56 for that angle, guess what? You did it correctly. Now I can focus on this last triangle and subtract these two from 180 to get that angle there. So 180 minus 90 minus 56, and that last angle is going to be 34 degrees. All right, cool. Like giant puzzles, giant triangle puzzles. There is no Delta math homework for day 2, so you guys have a night off. But if you kind of struggled through this video or coming up with these angles, please don't hesitate to reach out to me via Brave Square or email, and we'll see you guys for day 3. Thanks for watching.